Welcome to Next Gen Manufacturing Nexus. We're surrounded by amazing products every single day. But what about the hidden world of tiny mistakes, the almost invisible flaws that can turn a masterpiece of engineering into a total disaster? Today, we're diving into the secret world of manufacturing defects.
It all starts with just one little thing, a single mistake. That one mistake can snowball into a catastrophic failure.
And it's all because of one tiny, overlooked flaw.
So what are we really talking about here? Well, the Lean Suite puts it perfectly. A manufacturing defect is basically any time a product deviates from its original blueprint during the production process. It's that critical moment where the plan and the reality just don't match up.
And you have to understand, these are not just little cosmetic scratches. Oh no, we are talking about billion-dollar flaws. So let's really get into the true cost of what happens when things go wrong. The fallout is just massive. You've got huge product recalls, supply chains grinding to a halt, not to mention some seriously expensive legal battles. But honestly, beyond all the money, these defects can be straight up dangerous. The stakes couldn't be higher. So where do these little gremlins in the system even come from? Well, they really come from two main places. Either the problem is baked right into the design from the start, like a bad blueprint, or it happens on the factory floor during the actual manufacturing process. Let's take a look at both.
First up, let's talk about defects by design. This is when a part is basically doomed to fail before a single machine even gets turned on. Why? Because the problem is in the plan itself.
A perfect example of this? Sink marks. I bet you've seen these on plastic stuff all the time. They're those little dips or depressions on the surface. They happen because a thick part of the plastic cools way slower than the thin surface layer, and as that inside part shrinks, it literally pulls the surface down with it.
Now, what's so cool about this is that we can actually design this problem right out of existence. If you make sure the walls have a nice uniform thickness, everything cools evenly. You can use support ribs the right way to add strength without adding bulk, and you can even core out those super thick sections to get rid of extra material. It's a design problem with a pure design solution.
But, even if you have the most perfect design in the world, things can still go wrong when you're actually making the product. And these are what we call flaws in the process. Take a look at this. Weld cracks. These are an absolute nightmare for engineers. They're these tiny little fractures that can form in a weld, totally compromising its strength. This usually happens when the metal cools down way too fast or when the wrong materials are used, creating all this internal stress that just has to go somewhere. So here, the solution isn't in the design file, it's in the execution. To prevent these cracks, you need super strict control over the process. You've got to preheat the metals, make sure they cool down slowly, use the exact right materials, and keep those gaps perfect. It's all about discipline on the factory floor, but that relies on human perfection, and, well, that's where things can get a little tricky. For decades, we've had to rely on human eyes and some pretty basic machine vision to catch these problems. But all of that is about to change. It's time to meet the future of quality control, the AI inspector. Because just think about it for a second. What if a machine could see things that are literally invisible to us? What if it could spot a microscopic flaw faster and more accurately than any person ever could? This isn't science fiction anymore. It's happening right now. And at the very heart of this revolution is something called a convolutional neural network, or CNN for short. Think of it like a superpowered artificial eye and brain, designed specifically to see and make sense of images.
So how does this whole CNN thing work? Well, it doesn't just see a jumble of pixels like a normal computer. It actually learns to see patterns. It starts small, recognizing simple things like edges and colors. Then it pieces those together to see more complex shapes. And finally, it uses those shapes to identify what it's looking at, or in our case, to spot a very specific type of manufacturing defect.
But here's the thing. This digital eye isn't just born smart. Oh no, it has to be trained. It has to learn what failure looks like by seeing thousands and thousands of examples. And that training process is incredibly intense. The AI is fed a massive library of images, some good parts, some bad parts. It trains on one set, then gets tested on another, and this cycle of training, testing, and tweaking goes on until it can make incredibly accurate predictions all by itself. But what happens if you don't have enough pictures of broken parts to train the AI? Well, this is where things get really clever. You use something called a generative adversarial network, or GAN.
Just picture a game of cat and mouse between two AIs. One AI, the generator, tries to create fake images of defects. The other AI, the discriminator, tries to spot the fakes. This constant competition forces the generator to create insanely realistic defect images, giving us a virtually endless supply of training data.
Okay, so after all that crazy training, what's the end result? Well, it's a completely new benchmark for what we can even consider a perfect product.
The results are frankly mind-blowing. This chart, called a confusion matrix, tells a really simple story: how often the AI got it right. On the top left, you can see it correctly identified 260 perfect parts, and on the bottom right, it correctly identified 451 defective ones.
And the number of times it got it wrong? Just 4. 4 mistakes out of more than 700 parts. That gives it an absolutely staggering accuracy rate of 99.4%. Just pause for a second and let that sink in. In a field like aerospace or medical tech, where one tiny flaw can be catastrophic, that little fraction of a percent is everything. It's the difference between success and failure, or even life and death. This isn't just better quality control, it's a whole new level of safety and reliability.
Which brings us to a huge final question. With AI now achieving an accuracy that no human could ever match, are we finally on the verge of the era of the perfect product? A time when manufacturing defects are just something we read about in history books? That future might just be closer than any of us think.